Okay, all right. Where are we now? Now I need to figure out where we were before. Oh, okay. We have the convolution operation, backpropagation, and it works. The reason why it's first of all it's very slow, but another problem is that what is it? It can't converge at all because I don't have a transfer function. Because of that, it just bounces back and forth between the actual local minimum, and that's why it never gets to anything good. But it does approach it. That's good. So it is learning. It starts out really bad and it gradually gets better. Although it can get a lot better because there's just one layer and there's no transfer function. So it works, but not very well. So now I need to be able to visualize how well it's working, how close it's getting. That neural array. Let's add a few functions here that will do something useful. Okay, divide. That should do. Now we need to get mean squared error. CUDA neural array get mean squared error. Get mean squared error. Okay, parent and target. We need a target. And new tap neural unit result. Okay, no, tap neural unit, not tap neural unit. Pointer result. Result. Okay, if target, target, and result. Result here is a single value, a single floating point value that equals that tells you the mean squared error. That's what it means. Okay, if parent.array length not equals target.array length, that those must be equal, of equal size. For I equals 0, I less than parent.array length, we need to how do we get mean squared error again? We need a sum. CUDA neural unit sum. Mean squared error, we sum up. Oh, there's an equation. Let me. Okay, there it is. Okay. Mean squared error is the 1 minus n means average, the sum of y index minus y index hat minus target. Okay, so value minus target squared. Value minus target squared. Okay. Okay, let's see. Where are we? Value parent.array data minus target.array data, I think. Yeah, minus target.array data, and then we square it. Okay, I just want to make sure I get the equation right here. Okay, parent minus, how do you square it? Well, just multiply by itself. That's what squaring means. Okay, parent by the minus array data squared, and what does that mean? Sum plus equal, sum equals 0. Sum equals 0. We have to get sum here. Go to neural unit, just copy it, and sum. It's not a pointer. Sum. Okay. Sum equals 0 for I equal parent dot array length. Sum plus plus. No. Okay. Do I have to? Yeah, I need to. What do I need to do? Yeah, I should do it. I don't think there's anything different here. Okay. If parent dot array length is more than 1, we sum equal sum divided by parent.array length. That's the average. Okay. Pointer result equal sum. And that's it. We have a mean squared error. Okay, do we need to copy it up here? Oh, there's a lot of things I forgot to copy up here. It's below divide. Okay, give mean squared error, and then stop. Okay, now we need to write it down to display it, save it, save. Okay, we need to save it somewhere. Get output. Okay, where was it? Feed forward array, backward array, bound get output result. Okay, we just need to do it right here. Whatever the last one is, we don't need to be perfectly accurate, just something that's close enough. Get mean squared error, result, and source. No, source result. Source. No, source result. They should be the same basically. Source is what we feed in, result is what we get. They should be the same at the end of the loop. I don't really care if they're exact, just as long as it's going down. Source result, MS error. Okay, we need MS error. Okay, could I neural unit, MS error, type neural unit. Or unit, MS error. Okay, type unit, and MS error. Now we need to display it. And that means a draw text function, which is more complicated than it sounds. Okay, to do draw text, I'm going to use these functions right here. Enumerate and install fonts. Text out, ITO8, move to X. We're going to use text out. And in window, type window. Okay, now let's implement a draw text function. Type window draw text. Type window draw text. No, text out. Draw text. LPSTR. LPWSTR. What is it? The text out. Oh wait. Draw text. I need to know. I need to make sure I know what it means. LPCWSTR text out W. That's not what it is, but okay, text out W. We don't need that. Text out, bold text out. Okay, HDC. Do we need HDC? Maybe we do. Okay, HDC, can it be null? Handle to our device context. It cannot be null. HBC gets DC. Oh, that should be bitmap. Type bitmap. Bitmap show HDC equal get DC, release DC. Type bitmap. Type bitmap, text out. We don't need all this. And where is that? HDC. Wait, where are we? Here. Get DC parent dot window handle. Parent dot window handle. Parent release DC. Parent dot window handle HDC. So far it's looking good. Is it parent dot window handle? Okay. Text out. Okay. What does it do? Text out HDC. X. We need an X. Long X. Long Y. Okay, X, Y. Okay, LPCWSTR. Okay, that doesn't make sense. No, LPCWSTR. Text. Okay, and long. Unsigned long. No, double word. Not double word. Why double word? Length. Okay, length. HDC text and length. Sounds simple enough, but it's more complicated than it sounds. Why text out? Explain to add a limit to a hint file. Browsing. Define text out W. Expand to text out W. Show potential fixes. Okay, help me understand H file. No. Text out. Array size text. Yeah. Yeah, there's nothing here. Okay, text out. Okay. It sounds simple enough, but I'm sure there's something else I'm missing. Okay, double word text out. Okay. Now, tap window text out. Function for what? It's right there. Ah, whatever. It's just being stupid again. Okay, tap window text out. What is it doing? Okay, I'm missing something. Oh, of course. That's why. Okay, that's the problem. Just being stupid. That's me being stupid. Okay, save everything. And now text out. Get me square error and write it down. Text out and window. Okay, I'm gonna have to figure out how to do this here. Now we need to figure out how to draw the text. It's a lot more complicated than it sounds. Okay, we have this right here I was planning on using. C buffer, is it double char? Yeah, double char. Double char C buffer. Unsigned long. Double char C buffer 496. Okay, I think I got this from right here. S.F. Or is it WF S.F? Okay, WS.F. Is it S.F or F real secure? S.F. What is it? Now C buffer. What else? Error. And there's something else I'm supposed to add. Error equals. I'm gonna have to look this up. Okay, I got it. 4. Okay, ampersand 4.12 F. That means point a floating point value with 12 digits of precision after the decimal point, and MS error. MS error. Okay. Okay, that should do it. Now L. Is it L? Oh, that's why I hate about this. Okay, C length equals this right here. Okay, X equals okay, 10 plus bitmap dot bitmap width 16. 16 is the size of the text, I think. Okay, C dash buffer C length. Okay, we have it. We should have it. I hope we have it. Window text out. Okay, now save. And then rebuild. See if it works. Come on, rebuild. It's getting slow. Okay, let's see if it works. Oh, there it is. And it doesn't work. F. Why is this part that failed? I've been reading up on Stack Overflow and discovered that everything I thought was going on here was totally wrong. It's not WS.F. WS.F is a different function from SW.F. Okay, SW.F. Okay, that's a completely different one. Non-initially passed as a parameter to V. Not D. F. L is that's stupid. It's SW.F versus WS.F. That's doesn't make any sense. It's two functions that do completely different things that have the same name. It's just I have no idea. No. Okay. We made a few mistakes here, so let me fix that. Okay, next error is that SW.F, the function that's new, as a variable, as a parameter where you specify the maximum size of the buffer, which is actually a good idea, but it just wasn't visible. So let me try it again, see if it works. Yep, it works. Although now the convolution is very weird. Okay, so the mean squared error is fluctuating back and forth between 0.09 and 2 and 7. So it's really not going anywhere. Okay, just fluctuating back and forth. So instead, I'm going to try something different. Okay, so instead of just calculating the error once per image, I'm going to get something smoother by adding a sum value here. Set the sum to 0. Oh, we need a value. Ah. Okay, we need to no. This is getting very crowded. We need to separate all this into different functions as we test everything. Sum equals 0. Value. Get mean squared error. What's get mean squared error value? Oh, we need get mean squared error inside. Inside here. Get mean squared error value. Okay, sum plus equal value. Value. Sum divided by ms error. Error equals sum divided by 5. We only have 5. We definitely need to move this into a different thing because it's just not working correctly. Oh, maybe that's why it's not working. I'm not doing all the images. Now let's just test it. We need to move this into a different function. That is not working. Okay. Void. Run network. Network. Okay, type neural network. Network. Or train network. Okay, type neural network. Now we need a data set. Where is everything? Oh, you only have one. So image list. Okay, train network. I just copy everything here. That no set image RGB. Get output, get mean squared error sum. Set image RGB. We cut and we paste. That neural network set image RGB source image 0. Train network for image width, height, and depth. No. Oh. Okay. Type neural array. Okay, I'm just trying to transfer everything here into its own function. Source. Why I have two sources? I don't know. Source. We don't need this here. In fact, it really should not be here. Okay, set image RGB, source, result. Source, result. Train network. Oh wait, that doesn't work. You know what? I give up on the whole train networks thing. I'm just not ready for that yet. Maybe it will make sense at some point, but we're not there yet. Let us make sure we have everything working. Okay, that's a more valuable thing. It's not really going down a lot, but it seems to be going down, or it's getting steady. I'm not quite sure what's not working, but let's figure that out now. Okay, let's try drawing a network. Void draw network. Okay, type neural network. Network. Okay, unsigned long I for I equals 0, I less than network dot network. What the hell? Why is that not working? Type neural network dot net. What's wrong? Must be class tab but has type neural network. Really? Type neural network. What the hell is wrong with this? Type neural network. Oh, it's getting really weird now. I don't know what it's talking about. Type neural unsigned long I. Why? Network dot network length. Isn't that right? What is it complaining about? I plus plus. I plus plus. So what? Oh, okay. Okay, that's where network length. Oh, network. Okay. Okay. C. Let's just copy this down here. Copy. C buffer equal S.F C buffer 496 outputs. Okay. Outputs MS error, not MS error, nothing. Okay, C-length as output 4. Do we S.F? No. Outputs C buffer C length plus no wait. Oh, it's 4 now. 4j what am I doing? 4j equals 0. Oh, that's for particular layer. Yeah, it's that particular layer. Oh, 1 0. Now I'm getting it. 4j equals 0. J less than min 20. Min 10 should be enough. Min 10 layers. Oh, now we need to get a layer. I keep forgetting these things. Okay, where am I? I've been typing this thing right here. It's just I need to draw the text of the buffer of the layer. Okay, draw layer text out. Where are we? Where are we? Okay, type window text out window 10, not 10, x. We need a value here. Okay, 10 minus 16. Now we'll draw it someplace. Outputs if it works, we need to know where we're going to put it. 16 times 1. Ten plus 10. Okay, we need to know where we're going to draw it. Draw neural networks. Long X, long Y. Okay, it's X plus, oh, what am I doing? Oh, it's X here. X value is just the offset. Y value, Y plus, it's 16, no, Y times 16. Actually, it's Y times 16 plus, times 16 plus 1. Okay, that might be wrong, but let's see what it gives. Okay, outputs. Okay, let's test it out. See, make sure it works. Whoa, what am I doing? Oh, it's messing me up again. Type window text. Why is it doing that? C equal W split F layers dot layer outputs. Okay, layer outputs dot OA data dot J. Let's see, make sure it works, and then we expand later. Oh, what is this? Oh, shoot. Void if layers. Okay, nested functions are not supported. Void. Okay, draw network. And network 10 plus bitmap dot width 16. Oh no, actually it's 16 times 2. Dot width 16 times 2. Okay, 16 times 1, just to make sure. X times 2. Okay. Okay, should be right. Build. Okay, does it work? Does it work? Yes, it works. Oh, at least it compiles. I don't know if it's going to work right. No, oh, it's way down here. Way in the wrong place. So I'm going to have to move it. Wait. And I think I got it. We have to put a space between the letters just so they don't mess with each other. Okay, other than that, it should be right. Okay, there's space between the letters right here. And then let's try it again. Let's rebuild. Ah, it looks okay. It looks okay. Yep, it looks the way it's supposed to. Okay. Now let's increase this to 20. And let's start adding stuff, other stuff here. Type window text out, outputs, weights, weights. Let's just copy here. 16 plus times 5. What? Whoa. That doesn't work. 16 times 5 plus 16 times 1 or times 0. Okay. I'm pretty sure I'm getting this wrong, but let's rebuild it, see if it works. Okay, it works. Okay, everything's in the right place. Okay, everything's in the right place. Let's move, make sure we're in the right place here. Weights, outputs. Later we're going to learn how to draw the networks into a file, but for now that's way too far away. Vectors, copy vectors. Vectors, copy. And the most important one is deltas. No, deltas. Uh, deltas. What am I doing? Deltas. Okay, 16 times 0, 16 times 1, 6 times 2, and 16 times 3. Okay, that should do it. We build it. See what happens. Okay, there we go. This allows us to actually study what's going on here. Because if we made a mistake somewhere, then this should help us be visible about it. That's the deltas. Is the deltas moving too quickly or is it moving too slowly? You can see right here. The deltas are sometimes going out of bounds. 1.8, 2.8, 3.8, that's way too high. And this is the cause of many of our problems. It's just moving too fast. Or is it moving too slowly? It looks fairly good, but something is still wrong. I don't know what it is. Something is still wrong. Okay, now we need to figure out what it is. But maybe nothing's wrong. Maybe we're just missing something. But anyway, let's try adding a few things, see if that fixes it. Okay. File, new, file, header file. Okay, tap neural layer bias. Let's just copy bias. Copy. Back once. Oh, shoot. Back once. Copy, transfer. TANH. We're going to separate the layers, the transfer functions, in their own layers. TANH. TANH. Tap neural layer. TANH create. TANH create. Width, height, depth. Nothing to see here. There, TANH. Is it TANH or transfer? Not transfer. Let's just have this, a single transfer function. I don't want to create a separate file for each transfer function. Transfer. Transfer is just my name for activation function. Basically the same thing. So transfer. Okay, here we should add something to select different transfer functions. Height, width, height, depth, and transfer. For now, we're not going to do anything about it, but layer type equal transfer. We don't need to create anything. Everything's the same. Here we should add something to select the transfer function, but for now I'm not going to do that. Transfer create. Now transfer. Okay, transfer create. Bias feed forward. Bias backpropagate. No, transfer backpropagate. And no update weights. We don't need to update the weights. Transfer destroy is no transfer destroy. Press the wrong button. Transfer destroy. Come on. Okay, we don't need to delete anything. It's all the same thing. Okay, everything's right. Backpropagate. Okay, now to do the transfer. Okay, that would be in type neural array. Where's neural array? Okay, neural array transfer forward. That should be matrix, close to matrix. Matrix forward, transfer forward. Same as matrix, and then we just copy it here. Result source, there's no weights. Result source. Okay, how do we transfer? Okay, if result source equals 0, and we return 0 if weight.array length not equal whatever length. Okay, if no result dot array length not equal source dot array length, return 0. That must be the same size. Okay, for we already have this. For I, no, that's I array length. Okay, we also have the transfer function somewhere in here. It's down here. Tonnage function. Is it? Oh, I hope I get it right, because it's not as simple as it sounds. Okay, tonnage function. Transfer a null array. Where am I? Null array. Transfer function. Oh, we also have to specify which transfer function we're using. Now transfer forward. Transfer forward. Transfer forward. Unsigned long. Unsigned long transfer. Okay, unsigned long transfer. Okay. What's this? Result dot array length. Unsigned long I. Sign long I. We need to count to every single one. Tonnage function. Okay, result dot I equals tonnage function source dot I. Okay, so far so simple. Is it source? Oh, source dot array data. Oh, dot array data dot I. Oh no, array data dot I. Okay. Okay, so far so easy. Return 1. Okay, transfer reverse. It's called reverse, so we keep all the parameters the same. We just okay, we also need a source result outputs. Okay, tonnage derivatives. Tonnage derivative. Okay, it's tonnage derivative. Result source. It's source. Result times tonnage derivative. Tonnage derivative outputs. It's source dot array data dot I equals result times tonnage derivative outputs dot array data dot I. So far so good, but we're missing something here. Outputs. And okay, now that we have transfer function, let's add it back to the source thing. Okay, well, we transfer forward, header, transfer feed forward, no, transfer forward. Okay, result is next dot outputs, parent dot outputs, and we'll fix that later. Right now we don't have time for this. Okay, transfer reverse is the same parameters. Okay, we're missing something else. I get the feeling we're missing something else. Yeah, probably not. Transfer backpropagate. Okay. What? No layer transfer. Why is that here? I don't need this. I don't need this. Oh, I don't know why that's here. Okay, not the outputs. Okay. Next up layer deltas. parent.layer deltas. Parent.layer deltas. And next parent.layer outputs. Okay, that should work. Transfer.backpropagate, transfer destroy. There, transfer destroy, and so far so good. Okay, now let's clean this up. Layer transfer. Transfer just activation layer. Okay, layer transfer and save. Come on, save. Layer. Transfer. Save. Okay, now for neural network. Okay, neural network. Okay, add layer transfer. Somewhere next to add layer null. Let's add them in order. Feed forward array, add layer convolution, add layer transfer. Add layer transfer. With high depth, unsigned long transfer. No. Unsigned long transfer. No layer transfer create. Transfer create. Copy. And of course we need to add it to a list of includes. Transfer. Add layer transfer. We have transfer here. Okay, is it the same? Yeah. No layer transfer create. No layer transfer create. Oh, yeah, it's fine. It's just being weird. Okay. Let's copy this here. Don't have to retype it each time. Okay, transfer. Operation. Transfer feed forward. Okay, convolution. Backpropagate. Propagation. Transfer. Transfer feed forward. And then there's no update weights. And transfer. Oh no. Stop it. Oh really? Why is it doing that? Did I copy it wrong? It's not doing that anywhere else. That's a convolution transfer. Whoa, what am I doing? Whoa, what the hell am I doing? Transfer destroy. Transfer destroy. Okay. Okay, now back to the original. Where is it? I've lost myself here. Let's add a transfer layer. I hope it works, but it probably will not. Add layer convolution and add layer null. Add layer transfer. Three, 0. Add layer transfer 0. Build, rebuild. Oh, it didn't work. Slight error. It's forward then reverse. Yeah. That's a good one. Oh no, it's still... I didn't save it. Why? It's just being weird again. Come on. Let's see if that does anything. Oh. Oh, it messes everything up completely. So we made a mistake. Oh well. Let's start stop again. Something went catastrophically wrong.